Hello, welcome to Kogence and thanks for your interest. Kogence is a collaborative problem solving platform meant for scientists. It has been designed and developed by scientists for scientists. It's a full ecosystem. We have a very large uh, number of simulation environments that are already preset and preset up to execute with one click on the cloud. As you can see, we have several popular simulators out here: Quantum Espresso, Elk, uh, Labs. These are some of the software that are popular with material scientists. Then you also see a lot of machine learning software here, like Cafe, TensorFlow, Theano. And then you see some general purpose software like MATLAB and Octave. Uh, there are a whole bunch of other software available which is for finite element simulation, for example, like COMSOL. Anyhow, if you look at any of the simulators, they come up with some instruction of how that simulator can be used on Cogent's platform. And if you go all the way to the bottom of the page, you here see various models, public models that are available on the Cogent's platform. And you can also reach these models through our model library link. There are a very large library of public models available on our platform. And this library is searchable. So you can say, for example, mechanical stress. And you will see a list of models that are built around mechanical stress. You can look at it, what that model is doing. You can see some description. Software used is COMSOL. COMSOL is a finite element simulator. You can see details of step-by-step instructions on how you can use COMSOL on Cogents. What are the results of the model? What are the other similar related models available on our platform? And the beauty is that it's a Wikipedia of scientific models in a way, and it's a live Wikipedia. When I say live, meaning you can actually execute these models on the cloud right from here by clicking one or two buttons. These buttons are inactive right now because I have not logged in. So to execute the model, you need to log in. So you can log in here. I already have an account. If you don't, you can sign up. Everything is free. There is no credit card required for signing up. And as you see that once you sign up, these buttons become active. You can copy the model, meaning you can clone it. If you don't own the model yourself, then you can copy it before you run the model. You are not allowed to change somebody else's model. So even if a model is public and you want to execute it, you would have to first make a copy. It's a collaboration platform. So your models can be public, or you can make the models private. If you make the model private, then you can just add an email address of your colleague with whom you want to collaborate, and you can choose whether you want to give him only read permission, or do you want to give him write permission so that he can actually edit your models, or do you want to give him execute permission as well? So when he will be execute, if you give him an execute permission, then you are giving access to your CPU, you are giving access to your software licenses, you are giving access to your screen sharing. So the recipient with whom you are sharing your model does not require anything. He does not require machine. He does not require machine setup. He doesn't require software. He doesn't require any screen sharing software. Everything happens with just one tick mark here. And once you have set up the collaboration settings, then you go on the settings tab here and you select what kind of machine you want to run this model on. And it's completely dropped down, and you can see that we have really some supercomputing capabilities available here. You see 64 CPUs with 1 terabyte of memory available. And I believe we do have a 128 core machine available as well, which might not be available right now. It's not showing up in the drop down menu. So let's say you want to run it on a 16 core. 30 gig memory machine. So you just select it here, and this was a default setting, so I don't need to do the save. Then you go to the software. It's also a drop down menu. You can select any software you want to use. This particular model is console, so we leave the console there. And that's it. You press the run button, and this model starts going into the cloud. On the bottom here, you see the log message is being printed, and you see that it says that the visualizer is live now. So you go up here and you click on this visualize button, and after you click this visualize button, you would be able to latency free interact with 3D graphics on the cloud. So remember, this model is running in a data center in a cloud, and I will show you that this graphics. So now this is a console graphical user interface, and we are interacting with console, and this is a completely latency-free graphical interaction that we provide for the user. Your models can be very heavy 3D graphics, but you can have an experience just like the experience you get working on your local workstation. uh, this is a console graphical user interface, so you can do anything here that you usually do with software. You can change it in any way, you can save it, and everything is version controlled. Any changes you make here would be saved in the repository, and you can exit from here, uh, and your all the changes would be version controlled. The you might have noticed that these toolbar automatically folds up so that you get the full screen 3D view. If you want to close the machine, you can stop the job here, and that's it. You're back on your original screen where all the files got synced and version controlled here. Let me show you one more thing. So if you are using any simulators that are text based, for example, MATLAB, then you can also have we also have a code editor. So for example, these are the models that are built using MATLAB on our platform. If you open any of these models, you see what this model is doing. There is a some amount of description here, and then if you click on this files tab, you can see what are the files in that model. And MATLAB, as you know, is a text-based scripting software. So there are MATLAB scripts that actually run. This is a fully capable code editor, basically, and you can do any editing here. For example, you say uh, comma y, something like that, and you can save it, and then you can run it. I won't make these changes here right now, but that's how the platform works. Uh, Let me take a minute and show you our model library. Uh, as I said, this is a Wikipedia of scientific models. It's a searchable library. Uh, you can search by various terms, and every model comes with a dashboard. We call it a dashboard. It's basically like a wiki page. This page tells you what software was used for this model, some instructions on how to use that software, what were the results, and these are all auto-populated. As you run models on the cloud, the results automatically get incorporated here. What software was used here was automatically incorporated, and you can click this edit button here. And if you click on this edit button here, you get a fully capable editor here. This is a what you see, what you get editor. You can insert media, you can insert comments, you can insert formulas, mathematical formulas. So if you go here, you can type mathematical equations here. It's just like Microsoft Word, and you can save it. And and you can share this with this. This entire dashboard has a link. You can share this link with your colleagues. They will see this, and they will be able to run this model right away. Uh, every model also gets tagged by categories. If you see in the bottom here, these are automatically tagged categories. It's saying that it's a physics-based model. It's using finite element analysis. The simulator uses console. and you can follow any of these links. So for example, if I click on finite element analysis here, it will show you all the models around the topic finite element analysis that's available on our platform, and these are all could be across different types of software. Similarly, you can see what are the different computational methodologies available on our platform. There's some deep learning, density functional theory, Fourier model method. So let's say you want to look at some Fourier model methods. You go here and you see all the different optical and electromagnetic models on our platform that are using Fourier model method as a calculation methodology. You can look at this. This is a near field heat transfer between two gallium arsenide slabs. You can click on it and you can see what that model is doing. And again, this model is also tagged with different categories on the bottom here. And now, let's say you want to see what are the different models that use scattering metrics and are available for public consumption on our Kogence platform. You go here and you can see another list of models that are available that are all using scattering matrix method. And so it gives you a Wikipedia style browsing experience. This particular model is using a simulator called S4, which is a scattering matrix simulator. And then you can see a list of other similar S4 models available on our platform. So you can kind of browse through this and see what's useful for you. Uh, Thanks a lot for your attention. If you have any questions, you could send an email to admin@cogents.com, or you can go here on the forum link and post your question. We will be happy to reply any concerns. Thank you.